So the first thing you'll do is click on it on your desktop to open it up. And as you can see, it opens up right on the desktop and it just leaves pretty much a blank worksheet. And the key thing to know with Stella is that almost everything that you want is going to be underneath the task tab right there. So if you click on the task tab, you'll see a drop-down menu with a few different things in it. And the very first thing you need to do is initial fix. So we'll just open up initial fix, and it's going to want to ask us to put in our current date and time. And the easiest way to do that is just click current date. That gets today's date. And then for the hours, minutes, and seconds, remember that it's in Greenwich Mean Time. And the other really important thing to note, a lot of people will take their measurements first and then enter this in. Well, the computer will give you an error. In essence, the DR position needs to be before any sights happen. So it's safe to backtrack an hour or two, look in your logbook and get your ship's position from that time. So we'll just call it 1900 Greenwich Mean Time. And we'll write down our ship's position in there. Say we were at latitude 45 degrees 00 north, and maybe longitude 125 degrees 00 west. And then it's going to want to ask for your ship's course and speed. So say we were heading south at 180 at 10 knots. None of this is super critical. It's just important to get your first dead reckoning position in there. And it once you do that, it'll archive the current data and set you up with an initial fix. And now you can go in and enter any kind of information that you want, whether it be an azimuth or a star site or whatever. Again, everything is under the task menu, so you look under there and there's some things that you can do. Under Almanac, this is where you can look at different planets and stars and where they might be in the sky. Under Position Update, this is where you could update your initial fix if it's been maybe 6 hours or something. Under Rise, Set, and Transit, this is a common one that's used for determining sunrise and sunset and local apparent noon. Site planning is a way to take a look at what stars are available in your part of the world at your particular time. Gyro compass error is a good place to determine your gyro error, obviously, by azimuth or amplitude. And then site reduction is the big one where you're going to do a line of position from a celestial site. We'll quickly step through each of these again. Almanac is not really one that we use too much in the Coast Guard. Position Update, again, is just to update your position. The real first big one that we see is Rise, Set, and Transit. And if you're on a ship underway, you're going to click on Underway. Okay, so for Rise, Set, and Transit, we'll look at today's date, and it's going to want to know what time zone we're in, right? So we're in a 7 time zone, and we're west right now. We're +7, and that just happens to be where I am on the surface of the Earth. The height of eye is the height of your eyeball above the surface of the water, so it's 21 feet for the ship that I'm on. We want to know what's going on with the sun, so we enter all that data in, and we'll click OK, and it gives us, bam, everything. Sunrise, sunset, local apparent noon, civil twilight, nautical twilight, etc. Meridian passage. So these are great for quick calculations of sunrise and sunset if you just need to put them into the log, or if you need to answer the question of, hey, what time is sunset tonight, so we can do helicopter operations, for instance. So the great thing about Stella is you don't need to, clear this out. As your watch goes on, you're continuing to move through your watch, and the next task that you maybe want to do is calculate or take a look at what type of stars are going to be visible tonight. So you're going to just click on Sky Chart, and you're going to want to know, maybe in our case, the evening stars for the 12th of April 2015, and hit OK. And that gives you a star chart. So let me open this up a bit and we can see a little bit more of what's happening. Okay, for the sky chart, the spot in the middle is the spot directly over your head. So that's your zenith. And then the compass directions are labeled north, east, west, and south is off the screen right now. All the really visible and good navigational stars are located over to the right, and then you just kind of plot them in the sky. So again, this is the spot directly over your head. So the star that's closest to the spot directly over your head looks like number 21, which is Pollux. That's in the constellation Gemini. So that would not be a great one for a celestial observation because it's too high in the sky. Likewise, the star closest to the horizon due north is number 47, which is Altanin. That's not a site I've ever taken. Again, that one's too low in the sky for a good observation, but everything else in the two donut rings there would make good stars for observation. And the computer actually calculates the best 3 that it thinks you should shoot. It doesn't know anything about the clouds, but they're highlighted in yellow, 40, 26, and 10. So Kochab, Regulus, and Aldebaran, that would make a good fix. Now, obviously, you can do whatever you want. For instance, V is Venus. That's over here to the west. And I know that I'm on a north-south course, for instance, so I want to shoot a body to my west. And a body to my north. So I could get a good fix with Venus and Polaris at my current position. So that's something to consider. And then another task that you can do is your gyro error, right? So we do gyro error by azimuth and we do gyro error by amplitude of the sun. Doesn't really matter which way you do it in STELLA, right? When you do it by hand, amplitude is easier, but it doesn't matter in STELLA. So the first thing you could do is click under planning, and that'll give you your time, your date and your time for your current position, right? We entered that in off the log. Now for gyro error, you want to be exactly right. Okay, so I would want to edit my ship's position off the GPS if I was taking that fix. But since I'm at home and I'm not on a ship right now, we'll click OK. And then to do the actual site, we'll go to gyro error again and determination. So we'll enter in our date, the time that we shot the site, say it was 1942 and 26 seconds. And that really matters when you're doing gyro error. Say the azimuth that we shot the sun at was, say, 250. I'm making all these numbers up, so bear with me there. We click OK, and then it gives us a gyro error readout. So in our case, it was 85 degrees west. Obviously, like I said, I just made up the numbers, but all you need to do is enter the data in. It gives you the gyro error. So then you would save it to the log. Hopefully your gyro error is a little bit less than that. All right, and then moving right along, kind of the last big thing that we do with STELLA is, or we make site reductions by recording observations. So drop under the site reduction menu, under record observations, and again, date and time, 19, it's 43 right now, in 30 seconds. And then this menu will click down which body you want to use. So if it was the sun, the moon, any of these stars, and you can also just type in, say we shot the star Fomalhaut, it'll bring it up automatically, so that's great. HS, this is the height of the sextant, right? So it's exactly what you measured out of the sextant, not corrected for index error, not corrected for anything else. So say you shot that at 43 degrees and 23 minutes. And you can choose what quality you shot it at. I always leave it at average. This just lets the computer know if it should weight one site more heavily than another. So I usually just leave it at average. Your height of eye, again, is your height above the water. Index correction, that's something that we'll learn with the sextant, but it's basically the error in the sextant. So I know in this sextant that I use, it's -2. Temperature and pressure, you can usually leave those alone, but if you wanted to correct for them, you can. And then we'll add that measurement to our log, and we're done. If you had other ones, you could enter in 3 or 4, up to 25. You might be asking, like, okay, where's my line of position? You would need to go under task, site reduction, and compute the fix, and it gives you your position based on all the calculations it did. So in this case, again, I made up the star Fomalhaut, but it'll give you a line of position right there, and you can then print that out and add it to your log. Or if you were to enter like 3 or 4 different stars, then you could hit compute fix, and it would give you a position from that. So the key things we want to take away from STELLA is that it's on your desktop, on the nav computer, and almost everything that you want to do is under the task menu. It's not that complex. Everything is right here. Always start with an initial fix. If it's been a while since you're done a navigation calculation on the computer, definitely at least once every watch. And then you just kind of pick what you want to do, and you enter in the data that it asks for, and usually it just gives you your answer. So it's a great software. It's definitely something that you should just mess around with, because spending a lot of time in manuals or watching videos like this is not as productive as just messing around with it and seeing how it works. Probably there's somebody on your ship that knows how to use it. It's just a question of asking them. Okay, well, that's it for Stella. So thanks for watching and enjoy and happy navigating.